So let's take a look at the last chunk of problems that you have on your homework 1 sapling assignment. And I'm starting with question number 14. This one is not asking you to come up with a name of this big, huge molecule, but just figure out how many carbon atoms are in the longest chain in this molecule. And that's kind of intimidating because this is a really bulky molecule. So let's see if we can see if I can help make this a little bit easier for you. When you're looking for the longest carbon chain, remember that you can start at any endpoint. Any one of these carbons could be the end of the chain. And you are trying to get to another end. So maybe you're connecting these two carbon atoms, or maybe you're connecting these two, or maybe you are connecting these two, or something like that. So you kind of have to look at every single possibility. I mean, some of them obviously, like this, you don't have to look at that because you know that that one is definitely not going to be the longest. But basically just, play around with a few options and see if you can figure out which, I think I already drew that one. I'm not counting any of these. I'm just drawing possibilities. Which one might possibly be the longest continuous chain of carbons. That's all that it's asking you to do. So it's going to take a little bit of trying a few options, but I know you can do it. I believe in you. The next question and the rest of these questions, they're asking you to draw structures of molecules from their names, which is not something that we practiced. We practiced looking at a structure and coming up with the name, but not this way. So let's practice this a couple times. When we have the structure, when we have the name and we're trying to figure out the structure from the name, we want to kind of work our way backwards. So here we know it's 1,1-dimethyl cyclohexane. And what I'm going to do is start at the end. This is a cyclohexane. So reference your table 12.1. Hexane means that there are 6 carbons. Cyclo means that they are in a ring. So I know that I have a 6-membered ring like that. And that's where I'm going to start. And once I get the parent chain drawn, then I'm going to look at the substituents. My substituents are 1,1-dimethyl. Now, when we're drawing these molecules ourselves from scratch, we get to just number however we want to number because there aren't any substituents on it yet. Once we get it numbered, then we fill the substituents in. The name is telling us carbon number 1, and also on carbon number 1, there are 2 methyl groups. If you look at your table 12.2, you'll see that methyl is the name of a 1-carbon substituent. So here I have drawn 2 1-carbon substituents onto carbon number 1. Let's see what's next. Which one represents the structure of 2-methylbutane? There's 2 different ways that you could approach this problem. One way, maybe what you could do, is draw the structure of 2-methylbutane and then try to match it up with one of these ones that have been provided for you. The other thing that you could do, your other option, would be to name each one of the provided 5 structures and see which one is actually 2-methylbutane. Since we don't have a lot of practice with drawing the structure from the name, let's practice that. So if you're given the name and you're asked to draw the structure, the easiest way to approach it is to start with the parent chain. So I'm going to start with butane. Looking at table 12.1, butane is a 4-carbon chain. And then I'm going to number that chain. And remember, when we're drawing it, we can number however we want to number because the substituents haven't been placed yet. So there's my butane, and it's numbered. And now I'm going to deal with the substituent. My substituent is on carbon number 2, which is right here, and the substituent is a methyl. If I look at table 12.2, I can see that methyl is the 1-carbon branch. So there I have drawn a methyl on carbon number 2. And now you just need to match it up and find the structure that matches with what the line structure. It looks like you can choose more than one. These square boxes usually mean that you can choose more than one. And let's see what else we have. Draw the structure of 2-methylbutane. Well, that looks familiar. Draw 2,2-dimethylbutane. You can totally do this. I believe in you. Start by drawing the butane. Look at table 12.1. Look up what butane looks like. Draw that out. Number the carbons. Find carbon number 2. And draw 2 methyls on carbon number 2. What do we got next? Draw 2,3-dimethylbutane. Oh, you can totally do this. This is almost the same thing. Draw your butane, number the carbons, find carbon number 2, give it a methyl, find carbon number 3, give it a methyl, you're done. And the last one, draw methyl cyclohexane. This is the one in one of the videos I kind of warned you about. There's no number here. It's kind of weird, but we can do this. So again, we want to build this molecule from its name, starting at the end of the name, the parent chain first. This is a cyclohexane. Look at table 12.1. Hexane means 6 carbons. Cyclo means it's in a ring. And now let's look at our substituent, methyl. It doesn't say where it is. It just says methyl. Methyl, look at table 12.2. Methyl is your 1-carbon substituent. So we want to draw a 1-carbon substituent on this molecule somewhere. It doesn't tell us where to put it, but it doesn't matter where we put it. You can put it right there. Or you could put it right here. Or you could put it on any carbon. It's not going to make a difference where it goes.